Hey students, Thrasher here. I am going over our inverse square law practice homework. This might end up being a long video because I want to go over all the questions. It's optional to watch. Maybe you skip ahead to problems you weren't sure about. Use this video, or don't, to the way that best helps you, okay? To help you prepare for our quiz. Now what I have up here is the graph from our notes, the inverse square law. What is that inverse square law? And there are going to be times when I think typing out would be helpful. So I have my keyboard. If it's a little loud, I apologize. I'm doing the best I can. The inverse square law really just says that the intensity of something is the inverse of the square of the distance. Hence why it's called the inverse square law. Now that's why I wrote down this in our notes. The intensity is related to the inverse, that means 1 over, of the square, that's d squared. That's what this graph is showing us. It's showing us that when the distance r doubles, well, double, that's 2, squared, that's 4, the intensity is 1/4. So that's where I'm getting these fractions from. To be honest, team, it's possible on your quiz you won't get this graph. I know it's helpful, but after we've done these practices, you shouldn't need this graph to refer to, in my opinion. So if you want to figure out what the fraction is, again, it's the name. It's the inverse of the square of the distance. Okay, it's the inverse. That means I go 1 over. And the square, that means it's raised to the second power of the distance. That's the fraction. So when it's triple the distance, well, okay, that's 1 over square of triple. Oh, that's 1/9. If it's 1/5, or it's 5 times the distance, the intensity is, okay, it's the inverse of the square of 5 times. That's 25. Again, if you know your squareds, maybe you realize it's a pattern. It's 2 squared, 3 squared, 4 squared, and it's just the fraction of that. Anyway, that's what it is in general. Let's go through these questions, okay? Some of them are very good quiz questions, not because I think they're necessarily challenging, but they can show levels, meaning a kid could get a 3 or a 2 by showing they have some knowledge, but maybe they don't prove that they have exemplary knowledge by fully answering the questions, okay? So number 1 is one of those examples. It says there's these 2 hikers, all right, Thrash and Kalinsk. Thrash says that if I want to feel warm by the fire, according to the inverse square law, I want to be twice as far away. Okay, do you agree with Thrash's reply? Well, you probably shouldn't. Okay, no, I don't agree with Thrash's answer. Okay, why? According to from the inverse square law, I'm going to maybe shorten a little. Well, doubling the distance makes the intensity 4 times less. Or you could have written down 1/4 as much. It's the same thing. Okay? Therefore, standing further back would make the intensity of the heat less, or it would be cooler. Okay? Kalinsk has the right application. Okay, they're the ones using the inverse square law correctly. When the intensity is the biggest, when is that? When you are the closest. Okay, I'm not saying this is maybe totally flushed out, but this sounds like a pretty good answer. Definitely a 3, if not a full 4 points. Remember, always say how you know, what physics you're using. If I was to critique my own answer, I might say something like the inverse square law says that the intensity is based on the fraction of the distance, okay, to the second power. Maybe you'd need that, but this is actually a pretty good answer what I have right here, okay? If you just said something like, oh no, Thrash is wrong, it should be weaker. Not bad, maybe that's like a 2, okay? Now this next question, it's good practice for the idea of intensity spreading out. I don't know if I'd put this on a quiz, it's just a little vague, but there's a pattern. Spray paint maybe follows this inverse square law. So when I'm 1 distance or 1 meter away, it covers 1 square. It's a little hard to visualize, but right here, this is twice the distance. So it spreads out. How many squares do I see? 1, 2, 3, 4. Ah, 4 right here. 3 times the distance, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 9. So I put in a 9th. But the intensity, how much butter I have to spread, it's 1/9. Remember, there's a trade-off. Okay, you move further back, it spreads out, but the intensity goes down. How many right here? You could just have counted the boxes, or maybe you recognize that 4 times further out, well, you're spreading out X and Y. That's 4 squared. That's 16 areas, And now each one of those 16 boxes is only getting its fraction 1/16th as much. That's the idea for number 2, okay? Number 3, another good quiz question, okay? Because you could get a good score, or at least an okay score, a 2, maybe a 3, just by proving you know what the inverse square law says in general. But to really get a 4, you'd have to be able to prove your ability to apply it. Okay, so what could a good answer look like? Well, the inverse square law says that the intensity of something goes down as it spreads out with the square of the distance. Okay, you proved you know what the inverse square law says. To be honest, if you wrote that down, that's kind of proving right away kind of a 3 level of understanding. Maybe a 2, maybe a 3. It might depend on the detail of the question. Okay, this one has a lot of possible details you can go. Now, let's apply it. I have this hose, all right, and it's spraying out, and it's measuring, or a student is measuring the pressure. That's like how hard the water is hitting something. Okay, now if you look, the pressure is going down, and the inverse square law says that the intensity goes down. So you might be thinking, oh, it shows the intensity getting weaker, so yes, it follows the inverse square law. If you type that after this, I'd give you a 3 on the quiz, okay? So not bad. But remember, if it's perfectly, and I do even write that word here, if it's perfectly following the inverse square law, it should be doing this, going down with the distance to the second power, that fraction. How can I check? Well, let's notice. From here to here, I'm doubling the distance. That's 2r, or you could say 2d, twice the distance. So, if the intensity is what I'm looking at, and I'm double the distance, that means I do the inverse of the distance, double, squared, I should be getting 1/4. From here to here, is 50 1/4 of 100? No, I'm going down by a half here. It's a different fraction from here to here. It's a different fraction here, okay? But it's not following this 1/4. It is not perfectly obeying the inverse square law. So how would I get full points for this question? So now I defined it, okay? I said in the beginning what the inverse square law says, okay? From 1 foot to 2 feet, the intensity should be 1/4 as much, since the distance doubled. 50 is not 1/4 of 100, so no, it does not follow the law. Notice what makes this a good, or in fact a great level 4 answer. You've defined what the inverse square law says, and then you applied it to the scenario, and you did it correctly. So number 3, this is a good answer. If you do something similar, give me what the law says, clearly apply it to the question, and have your obvious answer, yes or no in this case. Okay? Admittedly, I didn't follow this CER right here. Maybe I'm missing a sentence. Okay? The claim is maybe right here. Here's my claim. My evidence is the data right here, 50 psi, 100 psi, and my reasoning is right here. Actually, I do kind of have a CER, but it's just kind of in a different order. Sorry, I didn't realize about the CER until after I started typing. All right, next one. Number 5. Kind of a quicker question, maybe not so much likely to show up as your only quiz question because it's just some quick math. Again, what does the inverse square law say? It spreads out, and it spreads out as a pattern, okay, to the second power. So I have this light source. Light obeys the inverse square law. So if I'm a certain distance away and it's 1 square meter, and then I double it. So now I'm twice the distance away. Double the distance. The area of coverage, that's what I'm filling in here. The area of coverage, it says, is 4. Well, what happens if now I'm 5 times further away? That'd be like over here somewhere. Maybe I can't even fit it in. What would the area of coverage be? Well, what's the pattern? 1 squared, 1 squared. 2 squared is 4. What's 5 squared? 25. Oh, that would be the area of coverage. If I was 10 meters away, 10 squared, that'd be 100 meters squared. So you were just doing some quick recognizing that the pattern is the area spreads out as a square. This was not really asking about the intensity. The intensity, that's the inverse part, okay? Let's move on. Question 6. This one was asking for a couple of fractions. It says I have an astronaut. They're a certain distance away. So, you know, I got planet Earth. I got my astronaut right there. If instead they were once, twice, 3 times as far away, so right here, what would the fraction be? Well, the intensity is related to the inverse of the square of the distance. The distance is triple, so that's 3. So what's the inverse of 3 squared? Well, that's 1 over 9. Oh, so the first part of the answer, what fraction would it be? The fraction would be 1 over 9. Ah, then it says now multiply what is the force of gravity. So what does this mean, 1/9? That means whatever the force of gravity is here, at this spot, triple the distance, the force should be 1/9 as much. Well, I know that originally the force was 200. So can you figure out 1/9 of 200? You might need a calculator, but sure. Notice this is the same thing as doing 200 divided by 9. You get an answer of around 22 newtons. So that's the calculation right here. Okay, showing my little bit of math work. I'm multiplying the force of gravity acting at this new distance. Again, I realized by the inverse square law that if I'm 3 times as far away, it's 1/9 as much. I could even go up and check my graph. Okay, if I'm 3 times the distance, it's 1/9 as much. And if I knew the number here, I could find 1/9 as much. 1/9 of 200, use your calculator, that's about 22. That's number 6, okay? Number 7, another good quiz question because, again, you could tell me what the inverse square law is, get a 2. Try applying it, and even if you have some mistakes, maybe even get a 3. Maybe it's a little tough for this one to get a 4 to get full points, okay? So it says that I'm standing right here. It's too loud for Mr. Thrasher. I want the volume to be less. How much less? I want it to be 1/2 as much. I want the intensity to be 1/2. Where should I stand? Well, notice I'm a certain distance r away. It looks like B is 2r, C is 3r, and then 4r, etc. How can I figure out where to stand? Well, a lot of students kind of did a guess and check. For example, let's say it's right here. If Mr. Thrasher stands right here, the distance is 4 times as much. So what would the intensity be? You could scroll back up and look at the graph or look at the graph on your page too. But I'm going to remember, what's the intensity? It's the name, inverse square law. It's the inverse of the square of the distance. It's 4. So here the intensity would be, oh my gosh, standing here, the intensity is 1/16. It's way lower volume. It's like I'm whispering. It's 1/16. This would be too far away. I only want it to be half. Half is 0.5. 1/16, that's a decimal less than 0.0 something, okay? It's a small little decimal. So what about right here? If I'm double the distance, that would be 1/4. That also is too low. I only want it to be half as much. Where would I have to stand? Somewhere between A and B. And you didn't have to tell me exactly where you'd stand, but somewhere between A and B. What's another way you could have answered this? Especially if, say, you were given this graph on the quiz. What did I want the intensity to be? Half as much. Where is that? Look right here. It even shows you on the graph. I can't really draw straight lines using my pen tool, I'm sorry. But half as much. Notice, I'm somewhere between the original distance and double. Go back to the original problem. Somewhere between the original distance and double. Somewhere in between here. Okay, so what would I write down? Okay, maybe I first give an answer. Thrasher should stand between A and B. Nice. Why? The inverse square law says the intensity goes down with the square of the distance. Sorry, I know I'm making spelling mistakes. I want to, go fast. I'm going to ignore that right there. Notice, okay, first sentence, I gave the answer, my answer. Second sentence, I proved that I know what the inverse square law is, okay? Standing at B, double the distance, would be 1/4. Oops, 1/4. That's too low. So they should stand before B, somewhere between A and B. Okay? You didn't have to write it exactly like how I did it right here, but something describing how, well, if it's the inverse square law, half is going to be not twice as far away because that would be 1/4. Or maybe you said like, oh, Some students did a square root. You didn't necessarily have to do that, but that's possible. But some reasoning why they're standing where they're standing. Again, I gave an answer to the question. I proved what the inverse square law was, and then I applied it a little bit. That would be a 4-level answer. Okay, let's keep going. Number 8, again, a tough question, maybe the toughest on here, because you could get some decent score, but to really get full points, you got to be able to, in fact, interpret this graph. Okay, it says that this graph is not following the inverse square law. How can I prove that? How can I prove that the graph isn't following the inverse square law? Well, what do I know about the inverse square law? I know that if I double the distance, the intensity should become, okay, let's see, if I double the distance, the inverse square law, the inverse square law, I square the double. It should be 1/4. What does that mean, the intensity? It means the intensity should go down by 4. It should be 1/4 as much. I have intensities labeled up here. So if I could figure out where the distance doubles, I could see if the intensity is 1/4, okay? Well, where does the distance double here? Where do I go from one value to double? From 1 to 1.5, that's not double. How about here, 0 to 1? No, double 0 isn't 1, that doesn't work. Oh, notice right here, 0.5 to 1. From this spot to this spot, that's double the distance. That means on the graph, again, this is a tough question. If you have a question like this on the graph, you're unlucky, okay? On the bright side, you can retry any quiz in my class, but what this is saying that when I go from here to here, the intensity should be 1/4. Well, let's look at the intensities. You'd have to estimate, what is this intensity? I don't know, maybe around 1400. I'd accept a variety of answers because it's not, super crystal clear. If you said 1300 or 1450, I would accept that, but around 1400. What's the intensity? Oh, it deleted my line. What's the intensity around here? That's around 600. So let's do a test, okay? Is 600 1/4 of 1400? 600 divided by 1400. I bust out my calculator. Using my calculator, I get an answer of, I get 0.42. Remember, 1/4 is 0.25. This is not 1/4 as much. Or if you flipped your fraction, if you did 1400 divided by 600, that's okay. You should have gotten around 4 times the number, theoretically, but you wouldn't have, so it doesn't match that way either. Okay, so there's how I proved it. So what would my answer be? Again, this is a tough one, okay? The inverse square law says the intensity should go down with the square of the distance. From 0.5 to 1, these are inches, you didn't necessarily have to note that, okay? The intensity, I should maybe say, the distance doubles, so the intensity should be 1/4. Okay, I know I misspelled should over there. Looking at the math, okay, maybe 1400 divided by 600 is not 4 times as much. Or maybe you said 600 divided by 1400 isn't 1/4 as much. Something showing. Okay, therefore it does not follow the inverse square law. So why would this be a 4-level answer? I explained what the inverse law says. I applied it, okay? You looked at doubling the distance, and then that led me to my answer. Like I said, number 8's, I think, the toughest one on here, because you also have to interpret the graph. That's a little tough. You maybe got to do a little math. That's a little tough. Okay, if you were able to answer number 8, and you have a similar answer to what I have, and you did something similar, man, you should feel confident about the quiz next time we have it. Okay, just a couple more. We're just about done. Number 9, I see 2 stars out at night. Let's assume they're normally the same size, and they would be pumping out the same amount of light, but one of them is 4 times as far away. Would you expect it to be brighter or dimmer? So I'm asking about the intensity. Would the intensity be more or less? And then how many times? So this other star is 4 times farther away. So let's figure out the intensity according to the inverse square law. Okay? If it's 4 times as far away, what's the intensity? Okay, it's the inverse square law. It's the inverse of the square of the distance. The distance now is 4. That is 1/16. Use a calculator if you need to. 4 squared, that's not 8. It's 16. So the intensity is 1/16 as much. So first, easy question. Should it be brighter or dimmer? It should be dimmer. It should be 1/16 as much. Okay? If it was brighter, I would need an answer of like, oh, it's 16 times. But don't forget, it's an inverse. It's a fraction. All right? Do a little math and briefly explain. So maybe my answer would include that little bit of math right down there. The inverse square law says, maybe you do it this way. Okay? I is related to 1 over d squared. Usually, using your pencil, it would be a little nicer. Oh, that's also the inverse square law. Bam, you just proved to me you know the definition. I love it. Okay? 4 times the distance makes the brightness 1/16. Or maybe you said 16 times less. So the star would be dimmer by 1/16. Maybe you don't need to write the fraction again. Okay, nice. Okay, this one's maybe a little shorter, but you showed me that you know what the law says, this time as an equation. That's okay. I accept equations as proof. 4 times the distance makes it 1/16. You were able to use the equation, okay, and then you said it was dimmer. There's number 9. Okay, number 10, also one that's pretty quick. All right, usually even before you read the question, especially since you know what the quiz is on, you could probably start answering. The inverse square law says the intensity goes down with distance squared. Now, I said in my notes that that means something for an equation. That means in an equation, you should see, oh my gosh, lots of typing errors. You should see distance squared in the denominator, in the bottom. Well, what equations have distance squared in the denominator? Remember, this is my relationship, 1 over d squared. This is saying distance squared is in the bottom of the fraction, right here. Well, maybe I have a distance right here, but it's not distance squared. It's not this first one. How about, oh, look, right here. Bam, this one follows it. How about, let's see. Oh, it's tucked away right in here. Bam, this one also has it. Oh, so maybe I'm not going to type this. So it's the 2 equations I circled because they have distance squared in the denominator. Bam, that would give you a 4 if you typed out that last part right here as well. Okay, I know this is a long video. Maybe you didn't watch the whole thing. Maybe you jumped around. If you have questions, you could email Thrasher. Okay, but that's it. That was me going over the answers. Thanks a lot for watching.